The first step when we factor is to look for a common factor. That can be a number or an algebraic element that is present in every single term with no exceptions. You pull that out as a factor and put the rest into a parenthesis dividing through, and then keep looking until there are no common factors left. And you can pull out several all at once or one at a time. It doesn't make any difference to the final answer. Taking it steadily and being thorough is more important than trying to bite lots out at one time. So if we look at this example, 3x squared minus 12x. And my recommendation is that you start and be methodical. You start at the numbers, pull out any number factors you can, and then move to each of the different letters and pull out as many of those as you can as well. So if we start with that, what factor numerically can we pull out from 3 and negative 12? The negative doesn't really make any difference when we're looking for factors. Hopefully you can see that 3 is a factor of both those numbers. So we can pull out 3, and then we divide each of those terms by 3 and put the result in parentheses. So the 3 out of the x squared gives us just x squared. Dividing negative 12x by 3 gives us negative 4x. Then looking at the letters, both of these terms have an x in them. So we can divide this through by x, pulling the x out to the front. We get 3x times x minus 4. And at every stage of what we've done here, you could expand and get back to where we started. If we expand the first line, 3 times x squared gives us 3x squared. 3 times negative 4x gives negative 12x. If we do it at the second line, 3x times x gives us 3x squared, and 3x times negative 4 gives negative 12x. So each of these representations describes exactly the same thing. They just look slightly different, and we can use them for slightly different purposes. Your turn. So if you pause the video and then rejoin when you think you've factored this completely, we can take out the number 5 as a factor from both of these, and we can take out an x as well. If we do that a step at a time, you take out the 5, you get x squared minus 3x, and then you take out an x, you get 5x parentheses x minus 3. We look at this one. Doing the numbers first again, you can pull out a 3, and we get inside the parenthesis, we get 4x squared minus 1x minus 3. And you don't need to write the 1 because multiplying by 1 doesn't change it. Then looking at the x here, well, there's an x in this term, and there is an x in this term, but there is no x as a factor of this term, so we cannot pull out any x. We are stuck. We have to stop here, and we'd then be worrying about factoring this thing as a quadratic, which comes later in this slideshow. Common factors. We've got here, if we look at the numbers, well, they're all even, so 2 is a factor. And if you take out a 2, you may also see that they're all multiples of 3, so we can take out 6 altogether. 72 is 6 times 12, 18 is 6 times 3, 6 is 6 times 1. So if we pull out the number 6, 12x cubed y squared plus 3xy cubed plus xy to the 5. I'm not touching the letter part at all. I was just pulling out the numbers. We'll now look at x. There's x cubed here, x to 1 here, and x to the 1 here. So the most we can pull out is a single x as a factor from that. So pull out the x and reduce the x inside here, dividing through by x for every term. When we look at the y's, we've got y squared, y cubed, y to the 5. So the most that is common to all of them is y squared. So we can pull out the y squared as well. 6xy squared as the common factor of every term in the original expression. 12x squared, 3y, and y cubed. And again, if you expand this, you will get back to where you started. We'll move on to quadratic expressions. I'll take this up in the next video clip.